Bismillahirrahmanirrahim. Welcome back to my channel. Someone has requested to me to make a Doppler radar, and Doppler radar is only possible when you have a full duplex device. So this one, as you guys can see, HackRF, this is a half duplex device. I can either transmit or receive. But on the other hand, you have PlutoSDR, which is actually a full duplex device, which is right now is connected to my to my laptop. And you can see that Doppler radar flow graph using PlutoSDR, because PlutoSDR is a device that allows me to actually transmit and receive simultaneously. So that's why I won't be able to use HackRF to actually make any type of a radar. PlutoSDR, this is the transmitting antenna, this is the receiving antenna, and the range for your PlutoSDR without a firmware update is from 325 megahertz, if I'm not mistaken, all the way up to 3.8 gigahertz. Let's look at the flow graph and let's see the effect. So first, as you can see, a signal source, I'll be transmitting a frequency tone that is around 500 hertz, and I'll be transmitting, modulating at a frequency of 3.5 gigahertz. When you grab a flow graph, when you grab these components, it's already here. Just simply type in PlutoSDR, you will find it in your sources. So just do that. So just simply go to core, and within that you will find PlutoSDR, or just simply control F it and just simply type in PlutoSDR and you will find a sync. So I'm using a signal source, choosing a frequency sample rate of 2.4 megahertz, because when you divide this, eventually in Doppler radar, I want to see the effect that if I move my hand or if I move an object from here to here, I'll be able to hear a change in frequency in terms of an audio. This is what I want to observe using a Doppler radar. Doppler radar basically determines the frequency shift, so we can also see that, and we would also want to hear that. So by having a 2.4 megahertz of sample, if I were to decimate this with respect to 50 megahertz, 50 divided by, sorry, not 50 megahertz, divided by 50, I'll be able to get a decimation rate up to 48 kilohertz, which is audible using my laptop audio card. So first, it's just a simple transmission of your signal from your PlutoSDR transmitting antenna. And then on this, the next flow graph is actually just receiving this antenna, and we'll be transmitting at 3.5 gigahertz, as you guys can see this. And sample rate is exactly 2.4, and we'll be able to see this in time sync and frequency sync. So let me just quickly run this part of the flow graph and show you this. So once I run this flow graph, this is what you would observe. Now, as you can see, this is the attenuation. Let me lower my attenuation down here so you can see your signal. Bring this down. All right, this is what is being transmitted. As you can see by the flow graph, this is what is being transmitted by my PlutoSDR, and this is what is being received using my PlutoSDR with a GUI time sync and GUI frequency sync. So let's just quickly look at it. Okay, right here. So by having a minimum attenuation, you guys can see that this is what is being received. By increasing, if I have my attenuation gain like this, I can increase my receiver gain. See the effect? No, it's too high. Let me lower this down. Lower this attenuation down. It's clipping off. Lower this receive gain. And so as you guys can clearly see, this is what is being received by my SDR. So now the next part is this. Next part of this is actually using a low pass filter. Now what low pass filter will do, that when I enable this, so let me enable this, let me enable this, let me enable this, and I'm having some problem. Let me just enable this as well. So now what this is actually, once I receive this antenna, I want to actually pass only a component that is around 500 hertz, because this is where my tone actually is. So that's why I'm choosing a low pass antenna, low pass filter, and using a cutoff frequency of about 101 kilohertz and a transition bandwidth of 250 hertz. So this is, so I'm actually passing 500 hertz of 500 hertz of actual tone plus 500 some other stuff. So, and having a 250 transition bandwidth, that's basically mean that it's a very steep type of a low pass filter. I can do that. And having a decimation factor set to 50, now the sample rate was 2.4 megahertz. When I divide this by 50, now the sample rate which is coming out of this block after low pass filter and the entire flow graph afterwards is going to be 48 kilohertz. So I need to make sure I can do that. I need to change the sample rate, now 2.4 megahertz now. Now the sample rate has changed due to this decimation factor of 50. I can use that to actually decimate up till 48 kilohertz, which is because I actually want to hear this. Then I can monitor this using my time sink and my frequency sink after low pass filter. So I can do that. Let me just play this. And let me just lower my attenuation factor down. And this is what you are observing after low pass filter. Because it's a complex signal, that's why I'm seeing real and imaginary, both of them together. And this is the frequency sink graph that you are observing right now. So you can zoom in on it. This is what is being observed. And y'all can see this. This is around 50 kilohertz. This is what that low pass filter is doing, is actually looking at only 1 kilohertz of signal. And then after looking at 1 kilohertz of signal, it's just only focusing on that with having a transition bandwidth of 250 hertz. When I move my signal, as you can observe this, you will see a change in the graph as well. All right, you can see that as well. Now, after this, we use another filter, which is called band reject filter, that we want to actually look at only a certain part of a frequency component. So let me, by enabling this, I have a cutoff frequency of about 495 megahertz and high cutoff frequency at 505 megahertz. So this is a band reject filter. So that is also being set at 48 kilohertz because your sample rate was 2.4 megahertz divided by 50, that is giving you 48. So your new sample rate is 48 kilohertz. So you can see that. And then by taking this into a multiply constant block here, right here, basically this is what's going to control my audio. So by basically it's just multiply constant mean it's just audio gain. I'm multiplying it by some number, which is called an audio gain. And that audio gain block is right here, which is somewhere around here. Hold on a second. So that audio gain block is being controlled by this QT GUI range. So I can just enable this. So basically this is going to be a gain that is from 0 to 10 in an increment of 0.1. The default value is 1. So this is basically controlling the sound that you would hear from by moving your hand or by moving an object away or bringing close to your PlutoSDR. So let me enable this. And then after that, we're monitoring this on my GUI time sync and GUI frequency sync. So I can also enable this as well. And then after this, since everything is in complex, I need to hear it on my audio sync. So I'll be able to hear it. That audio sync needs to be enabled by using a block called complex to real. That will convert these complex signal into real signal because audio sync is only real. So then I'll be able to hear it. So this is a basic Doppler radar design in GnuRadio using PlutoSDR. So let me hit play. Let me turn down the attenuation. To minimum. And then you guys can see the effect. You see that change in frequency? Can you hear this change in frequency? Or when I bring an object because what's happening is this, that when the wave start propagating from this antenna, it's actually being received by a receive antenna as well. But some of the wave is also hitting this and is being reflected by this surface, is also being received here. That's why you can hear a different frequency tone. So this is basically a crude design of your Doppler antenna or Doppler radar that actually detects this. I can increase my receiving gain as well. I hope you will be able to hear this sound. So that's the idea behind Doppler radars. This is the way you can actually do these Doppler radar using GnuRadio and also your PlutoSDR. If you guys have any questions, just leave it in the comment section. I have actually followed a particular flow graph from Professor Jason's website. I will also leave a link. And if you have any questions, just leave it in the comment section. And please don't forget to like and subscribe to my channel. And thanks for watching.